The objectives of this topic are recognized characteristics of parabolas, graph parabolas, determine a quadratic function's minimum or maximum value, solve problems involving a quadratic function's minimum or maximum value. So the quadratic function in vertex form looks like this. F of x equals a times, in parentheses, x minus h squared plus k, where a doesn't equal 0, because if a equaled 0, this whole term would go away and we wouldn't have a squared anymore. And the squared is what makes it quadratic. We call it vertex form because HK, much like the center of a circle, is the vertex of the parabola. So H is what's subtracted from X. K is what's added on after the square. The parabola is symmetric with respect to the line X equals H. We would call X equals H the axis of symmetry. If A is greater than 0, in other words, if A is positive, the parabola opens up. If A is less than 0, if A is negative, the parabola opens down. So to graph something in the form a times x minus h squared plus k, where a isn't 0, first we would determine whether the parabola opens up or down. If a is positive, it opens up. If a is negative, it opens down. Then we determine the vertex of the parabola. The vertex will be hk, what's subtracted from x and what's added after the square. We'll find any x-intercepts by solving f of x equal to 0. The function's real zeros are the x-intercepts. So this makes sense because the x-intercept happens when y equals 0. Y equals f of x. Set the whole function equal to 0, we'll get our x-intercepts, and we call those zeros of the function. Then we'll find the y-intercept by computing f of 0. Again, this makes sense. The y-intercept is when x is 0. F of 0 means plug 0 in for x in f of x. So then we'll plot the intercepts, the vertex, and some additional points as necessary to get the shape of the graph. And we'll connect these points with a smooth curve that is shaped like a bowl or an inverted bowl. It's that U graph with the same shape, same general shape, just moved up, down, left, right, maybe stretched or shrunk, of our quadratic graph, the y equals x squared parabola. So let's graph the quadratic function f of x equals negative x minus 1 squared plus 4. First, we need to determine whether the parabola opens up or down. We look in front of the parentheses. There's a negative there, which means the coefficient is -1. Negative means that it opens downward. So the arrows will point down. Next, we'll find the vertex, hk. H is what is subtracted from x, and what is subtracted from x is +1. K is what's added after the square. That's +4. So +1, +4 is the vertex of the parabola. Let's find the x-intercepts by setting the function equal to 0. So take f of x, replace it with 0. We're going to go ahead and subtract 4 from both sides. Then we're going to take the opposite of both sides. We'll take the square root of both sides to undo the square using the square root property. But when we do so, be careful. The square root of x minus 1 squared is x minus 1. The square root of 4, when we take it in solving an equation, is plus or minus the square root of 4. So plus or minus 2 in this case. That gives us two equations to solve. X minus 1 equals 2, or x minus 1 equals negative 2. Add 1 to all the sides, we get x equals 3, or x equals negative 1. Therefore, the x-intercepts are negative 1 and 3. 2 points the parabola passes through are 3, 0, and negative 1, 0. So far we have 3 points, the vertex and the x-intercepts. Let's find the y-intercept by plugging 0 in for x. 0 minus 1 is negative 1. Negative 1 squared is positive 1, but the opposite of positive 1 is negative 1. And then negative 1 plus 4 is positive 3. So the point 0, 3, the y-intercept of 3, is a point the parabola will pass through. So we plot our vertex, 1, 4. We plot our x-intercepts, negative 1 and 3. We plot our y-intercept. Of 3. And then we draw the parabola through these points, and it opens downward. Let's say that instead of being given to us in vertex form, the parabola is given to us in ax squared plus bx plus c form. Well, the vertex then would be negative b over 2a, and the function value we get when we plug that in to the function. In other words, if h is negative b over 2a, the output is f of h, f of negative b over 2a. So we don't have to, I should say we're unable to directly see the vertex in this form, but we still get the vertex from this form. So the only changes in graphing, we'd still determine if it opens up or down. The change comes when we find the vertex. Instead of just pulling out hk, we have to solve for h. H is negative b over 2a. And then we have to plug that back into the function to find k. Then from there, we find our x-intercepts, we find our y-intercept, and the shortcut for the y-intercept is that when we plug 0 in for x, all it leaves is c. So the plus c is our y-intercept. Very similar to the b in y equals mx plus b. Because that's all that's left when x is 0. So we plot the intercepts, the vertex, any additional points we might need to help clarify the shape, and connect the points with a smooth curve, drawing our parabola. So we're going to graph the quadratic function f of x equals negative x squared plus 4x plus 1. And then we're going to use the graph to identify the function's domain and its range. So we're going to take it one step farther. after graphing. So A is negative. The parabola opens down. To find the vertex, to find the top, the maximum point in the parabola, we would do negative b over 2a. A, B, and C are the same A, B, and C we would use in the quadratic formula. A is -1, B is 4. So -4 over 2 times -1. That'd be -4 over -2, which is +2. So the x coordinate of the vertex, our h, is 2. We have to plug that back into the function. We need to find f of 2 in order to find k. So plug it in, plug it in. 2 goes in for x in both places. 2 squared is 4. The opposite of 4 is -4. -4 plus 8 is +4, plus 1 is 5. So f of 2 equals 5. The vertex is 2, 5. X-intercepts. Solve f of x equal to 0. So take f of x and replace it with 0. Then use the quadratic formula. That's a -b plus or minus the square root of b squared minus 4ac over 2a. A is -1, b is 4, c is 1. Plug it in, plug it in. Plug it in, plug it in, plug it in. Underneath the radical, we have 4 squared minus 4 times -1 times 1. That's 16 plus 4, or the square root of 20. The square root of 20 is the square root of 4 times the square root of 5, or 2 radical 5. Dividing top and bottom by -2, we would get +2 plus or minus radical 5. Now I'm doing that in my head because on the slide, we have a calculation to the nearest tenth. This is equal to -0.2. And that's only the plus. Recall it was plus or minus the radical 20. So -4 minus the square root of 20 divided by -2 would give us +4.2. So our x-intercepts are -0.2 and 4.2. The parabola passes through these 2 points. That's why it was important to get a decimal approximation. Saying 2 plus or minus radical 5 doesn't tell us much about where we fall on the x-axis. The whole point of finding the x-intercepts is to find points. We need to know where to plot them. So -0.2 and 4.2, that's much more helpful than the exact radical form. Find the y-intercept, plug in 0 for x, we get 1 for f of x. 1 for y. Makes both these terms disappear. All that's left is the +1. So we found another point for our parabola. The x-intercepts, the y-intercept, and the vertex. Draw the graph that goes through those 4 points. And just as predicted, the parabola opens downward. Earlier, I referred to something called the axis of symmetry, x equals h. X equals 2 here would be that axis of symmetry. All parabolas are symmetrical with their axis. It doesn't mean the graph has symmetry. The graph does not have any y-axis symmetry. So I believe we were also to find the domain and the range. So here's the graph. How do we find domain and range from a graph? Well, we start at the negative infinities and we move towards the positive infinities. And we see, does graph exist? So this parabola goes down and left forever and down and right forever. Since it goes left and right forever, we have graph at negative infinity. We have graph always through positive infinity. But if we start down at negative infinity on the y-axis, we have graph there. Eventually, we don't have graph anymore. Once we pass the vertex of the parabola, once we get past 5, there's no more graph. So the graph ends at the value 5. The domain is all real numbers, but the range is only negative infinity to 5, and that 5 takes a square bracket. So consider the quadratic function f of x equals ax squared plus bx plus c. If a is positive, then f has a minimum that occurs at x equals negative b over 2a. This minimum value is f of negative b over 2a. In other words, the parabola opens up, the vertex is in the valley. The vertex is a minimum. The minimum occurs at the x value, it occurs at h. The value itself is the output of the function, the k value. And condition 2 here says if a is negative, then f has a maximum that occurs at x equals negative b over 2a. This maximum value is f of negative b over 2a. So this is the exact opposite. If the parabola opens downward, then the vertex is on the hill. It's at the top. It's a maximum value. The value occurs at the x value. It occurs at h. But the value itself is the output of the function. The value is k. So x gives the location of the minimum or maximum value, and then the y is the value. That is the minimum or the maximum. So consider the quadratic function f of x equals 4x squared minus 16x plus 1,000. Determine without graphing whether the function has a minimum value or a maximum value. So this is nice. We don't even have to find the minimum or maximum value. But we could start with the vertex, negative b over 2a. That would be 16 over 8. That'd be 2. So x equals 2. Plug that in. Get the minimum or maximum value. But we don't have to do that. All we have to do is determine whether it is a minimum or whether it is a maximum. And all we need to know for that is, does the parabola open up or does the parabola open down? Well, A is positive. A is 4. That means that the parabola opens up. That means the vertex is in the valley. The vertex is a minimum. This function has a minimum value. Okay, now we do have to find the minimum or maximum value and determine where it occurs. Well, I already said where it occurs, and it occurs at x equals 2. How did I get that? X equals negative b over 2a. The opposite of negative 16 is positive 16. 2 times 4 is 8. 16 over 8 is 2. Plug it in, plug it in. 2 squared is 4. 4 times 4 is 16. 16 minus 32 is negative 16, plus 1,000 would be 984. So the minimum value occurring at x equals 2 is 984. Being a minimum value means that $983, for instance, isn't possible. 984 is the minimum value. 985, 986, all the way up through infinity. Those are possible, but not 983 or below. Not 0, not any negatives. Identify the domain and range without graphing. So that's why I'm driving home that minimum value was 984. Anything above, anything through infinity is possible. The range, the y values, is 984 to infinity. And then, like all quadratic functions, the domain is all real numbers because it goes left forever, it goes right forever. Whether it's opening up or whether it's opening down doesn't change that fact. What I want to make sure we get through today is an introduction to quadratic functions and some of the applications we can have of quadratic functions. So we know quadratic equations, anything with an x squared, nothing higher, no x cubed, x to the fourth, anything like that. And we know that y equals x squared, or f of x equals x squared. Is one of our parent graphs. It's a parabola, that U shape. It's got this dip. We know it's a minimum because it's a valley. Today, we're going to talk more about this type of graph. We're going to learn about some of the features. So what I'm going to do, instead of it being on a graph like that, I'm going to go ahead and draw two parabolas. one opening upward, one opening downward. And in fact, let's officialize that. When we say it opens up, we're talking about this shape. When we say opens down, we're talking about this shape. The point all the way at the top for one that opens down, or the point all the way at the bottom for the one that opens up. That's called the vertex point. So a vertex point is the minimum or maximum point. The point at the top of the hump, the point at the bottom of the valley. When we're moving a parabola up, down, left, right, it's that vertex point that we're actually moving up, down, left, or right, and then we draw it off from there. The vertex point on a parabola that opens down is a maximum. The vertex point on a parabola that opens up is a minimum. A parabola is symmetric. If its vertex is at 0, 0, it has y-axis symmetry. But if it moves up, down, left, right, it's not necessarily going to have y-axis symmetry anymore, but it will always be symmetric with respect to itself. So the line that goes vertically through the vertex that splits the parabola evenly, my crappy drawings strike again. But this is exactly the same as this if we fold it over. This exactly the same as that if we fold it over. That vertical line that goes through is called the axis of symmetry. And that's right in the light spot. Let me see if I can write that a little fancier. Axis of symmetry. If you're a Marvel fan, AOS might stand for Agents of S.H.I.E.L.D. In this class, AOS stands for Axis of Symmetry. The axis of symmetry, since it is a vertical line, is an x equals whatever x value it goes through. And the x value it goes through, since the vertex, just like the center of a circle, is going to be referred to as HK, the vertex x value is h. So the axis of symmetry is always going to have the form x equals h. Okay. Our vertex point is a minimum or maximum. The axis of symmetry will always be x equals h, the x coordinate of the vertex point. The maximum or minimum point is the vertex. But if we talk about a maximum value of a function or a minimum value of a function. Let me write that. Maybe down here. The max or min value, not the whole point, just the value. That's the output. That's the y. Y equals k. Or another way of saying y equals k could be y equals f of h. When the input is h, the x-coordinate of the vertex, the output would be f of h, what we get when we plug h back into the function. Because how do we get a y value? We take an x value, we plug it in, we evaluate, we get a y value out. We get a function value out. We get the value. So x equals the input, x equals h. That's going to give us the line. That's the axis of symmetry. Y equals k, plugging h into the function to get its output. That's going to give us the value. It's going to give us the y coordinate up here, or the y coordinate down here. So you see we're kind of bookending here. We started this unit with just learning about the various shapes. And now we're ending this unit by digging into this one shape more deeply. Maximum, minimum. Okay. Now, you remember when we did circles? We used HK then. It was the center of the circle. And we had a special center radius form. With parabolas, we have a vertex form. This is y, or f of x, equals a times the quantity x minus h squared plus k. So just like with the circle, hk was our center. Here, hk is the vertex. So if we're given something in this form, say for instance, f of x equals -2 times the quantity x minus 1 squared plus 8. One of the first things we can do is answer the question, what is the vertex? In other words, what is HK? Well, H is the thing that is subtracted from X. Here, X minus 1 is X minus H, so H must be positive 1. K is the thing that's added to the square. We're adding 8. Positive 8 must be K. So 1, 8 is the vertex. Another thing we will be able to ascertain from vertex form is whether it opens up or down. Well, remember, the one that opens up, that's y equals positive x squared. If we flip it over, if we get one that opens down, that means we have a reflection, y equals negative x squared. So when it's a negative out front, that's the one that opens down. So what we're going to do is look at A, the number in front of our x minus h squared, the number in front of our squared thing. If A is positive, then it opens up. But if A is negative, it opens down. And here our A is -2. So it opens down. So far with vertex form, we've been able to find the vertex, 1, 8. We have been able to determine whether it's a parabola that opens up or opens down. And it opens down. I'm going to keep a track of the things we've found over here on the very right. Vertex 1, 8. Opens down. I'm going to erase our general vertex form, and I'm going to move this up. F of x equals -2 times the quantity x minus 1 squared plus 8. And now I've got some room to work. Next up, let's find any x-intercepts and any y-intercepts that we might have. Now, x-intercepts, what do we know about that? Well, going back to very first lecture, x-intercepts that's where y is 0. And y-intercepts, that's where x is 0. Because if we're on the x-axis, we're not up or down any. If we're on the y-axis, we're not left or right any. If we go ahead and set y equal to 0 or set f of x equal to 0, that doesn't mean plug 0 in. It means set the whole thing equal to 0. So -2 times x minus 1 squared plus 8. What do we do next? We want to get the x by itself, so we got to get the x minus 1 squared by itself, so we got to get the -2 x minus 1 squared by itself. We can start by subtracting 8. This gives us -8 equals -2 times x minus 1 squared. We want to get the x, so we want to get the x minus 1, which means we need to get the x minus 1 squared, which means we need to get rid of multiplying by -2. So divide both sides by -2. I'm going to come over here for a little bit. -8 divided by -2 is +4. These -2's canceled. That leaves us with the x minus 1 squared. To get rid of the squared, we take square roots of both sides. So that just leaves us with x minus 1 on the right, but on the left, the square root of 4 is going to be plus or minus 2. When we're solving, when we're taking the square roots of both sides to end up solving for x, we have to remember to put our plus or minus there. Why? Because it's not just +2 times +2 that gives 4. It's also -2 times -2. So since we have plus or minus 2, that's 2 equations we have now. Plus 2 equals x minus 1, or minus 2 equals x minus 1. Add 1 to both sides, we get x equals +3. Add 1 to both sides, we get x equals -2 plus 1. It's -1. So we have 2 x-intercepts. The x-intercepts we found are the points 3, 0 and -1, 0. We still have to find the y-intercept. The y-intercept is going to be where x is 0, where we plug in 0. So x equals 0, we're going to take it, we're going to plug it in for x. We're looking for f of 0. That's -2 times 0 minus 1 squared plus 8. Use order of operations to simplify. Working inside the parentheses first, 0 minus 1 is -1. Exponents next, -1 all inside the parentheses squared means -1 times -1. That's +1. Multiplication before addition, -2 times 1 is -2. And then finally, -2 plus 8 would be +6. F of 0 is f of 0 is +6. That means when we plug 0 in for x to get our y-intercept, we get an output of +6. Okay, so we found the vertex. We found that this opens downward. We found 2 x-intercepts. We found the y-intercept. We have enough now to graph this parabola. Let's graph it. And then we'll answer a few more questions afterwards. Let's clean that up a little bit. Got to make sure that I have enough to go up to 8. Got to make sure I have enough to go left to -1. Got to make sure I have enough to go right to 3. Everything else will fit in here. Vertex 1, 8. So 1 over on the x and then up 1, 2, 3, 4, 5, 6, 7, 8 to get that point. plotted. It opens downward, so we're expecting it to hit the x-axis twice. That's why we have two x-intercepts at 3 and at -1. The y-intercept happens at 1, 2, 3, 4, 5, 6. So that left side of the parabola looks like that. The right side of the parabola is going to be a mirror image. It's going to come down. It's going to go through this other x-intercept. And if we wanted to, since we know that this point is left 1, down 2, since we know it's symmetrical, we can go right 1, down 2, and we can put that extra point in if we want. We can take advantage of the symmetry of a parabola. If we have a point on the left side, we have the equidistant point on the right side. And where does what feature of the parabola allows us to take advantage of symmetry? Why, the axis of symmetry. And that'll be our next question. The axis of symmetry, where is it? Well, the axis of symmetry is x equals our h. X equals whatever the vertex point is, that x value. 1. X equals 1 is going to be the axis of symmetry. And there we see it. It's this imaginary line through x equals 1, whereby the left side and the right side of the parabola act like a mirror image, with the axis of symmetry being the mirror. Since it opens downward, do we have a max or a min? Since it opens downward, our vertex is on the top. That means we have a max. And if we have a max, we can ask, what is the max value of this function? Well, that's going to be y equals our k. It's going to be the output of the vertex. The max value is 8. This literally means y equals 8 is the maximum y value. We can't have y equals 9. We can't have y equals 10 because it's the maximum. It starts going back down after it hits 8. And what do we call what we can have for our x and what we can have for our y? We call that domain and range. So the last two questions about this parabola, yeah, we're still on that vertex form. It's going to be domain, and it's going to be range. Well, guess what? For domain, all parabolas are either going to open up or they're going to open down. So it's either going to go up forever or down forever, not both. But no matter whether it opens up or whether it opens down, it will go left forever. It will go right forever. And since that means that if we imagine negative infinity and we move towards positive infinity along the x, there will always be graphs somewhere, either way, way, way up if it opens up, or way, way, way down. if it opens down. The domain of a parabola is always going to be negative infinity to infinity, all real numbers. The range is going to be determined by the max or min value. Here, the maximum value was 8. That means the y's can't get any higher than 8, but they can include 8. How low can they go? All the way. They can go all the way to negative infinity, which will take a parenthesis. So the domain, negative infinity to infinity. The range, negative infinity to 8. I'm going to take a look at this vertex form one more time. I'm going to move it down. So again, we have f of x equals -2 times x minus 1 squared plus 8. I'm going to take this out of vertex form. I'm going to expand everything, get rid of the parentheses. I'm going to put this in the form f of x equals ax squared plus bx plus c, standard quadratic form. Now, a can't be 0. If it is, then the x squared goes away and it's linear. It's not quadratic anymore. But a can be positive, just means this will open up. A will be negative, just means it opens down. The a is always the same as in vertex form. So we can expect our a to end up being -2. But how do we expand? First, we square this. X minus 1 squared means x minus 1 times itself. You can FOIL, or you can use the special formula. Either way, you're going to end up with x squared minus 2x plus 1. Then we have our plus 8. Distribute -2x squared plus 4x minus 2 plus 8. And we have -2x squared plus 4x, -2 plus 8 gives us +6. Some of the things are easier to find this way. For instance, if I'm plugging 0 in for x, I can see that we get that y-intercept of 6 pretty quickly. We could use the quadratic formula to solve the thing for 0 and get our 2 answers for x. But all of the questions that we had from vertex form, we can find in regular form as well, including the vertex. So here is our big trick. This is called the vertex formula, not to be confused with vertex form. And the vertex formula is that H equals negative B over 2A. Negative B over 2A. So what are A, B, and C? If we have f of x equals negative 2x squared plus 4x plus 6. Well, A would be negative 2. B would be positive 4. C would be positive 6. So H is negative B over 2A. That's negative 4, the opposite of 4, over 2 times negative 2. That's negative 4 over negative 4, which is positive 1. Huh. Well, how do we find K? We plug 1 into the function. And we don't have our original function. That's not what we're looking for the vertex formula. We have our f of x equals negative 2x squared plus 4x plus 6. And when we plug 1 in, when we find f of 1 to get our K, that's negative 2 times 1 squared plus 4 times 1 plus 6. Negative 2 times 1 plus 4 plus 6. Negative 2 plus 4 plus 6. 2 plus 6 is 8. 1, 8. Same vertex. It's good that we have this vertex formula, because otherwise, in order to go from ax squared plus bx plus c form to find the vertex, we would need it in vertex form. We would need to complete the square. So unless it specifically says, hey, convert this into vertex form, if it's just asking for the vertex, we can use the vertex formula. If it wants vertex form, we need to complete the square like we did with circles. Okay. Next up, we're going to have f of x equals negative x squared plus 4x minus 5. Let's find the vertex. Well, it's not in vertex form. So we'll use the vertex formula, negative b over 2a. Here, a would be -1. B would be +4. So the opposite of 4 over 2 times -1. That's -4 over -2, which is +2. So far the vertex has a +2 for the x value. Let's plug that into the function to find k. K is going to be f of h. In this case, that's f of 2. Which is what? Well, the opposite of just our x squared, the opposite of the 2 squared, plus 4 times 2, minus 5. Plugging it in there and there. 2 squared is 4. The opposite would be -4. If that negative was inside the parentheses, if we were plugging in a -2, it'd be different, but we have the minus on the outside. So that doesn't turn into a positive. That's going to stay a minus sign. +8 minus 5. -4 plus 8 is +4. Minus 5. 4 minus 5 is -1. So a vertex of 2, -1. Is this going to open up or open down? Well, A is negative. So it's going to open down. That means we're going to have a max. And in fact, that max value is what? I'm going out of order with the questions, but we should be able to handle them in any order. Once we have the vertex, the max value is the y. So a max value of y equals -1. An axis of symmetry, that's x equals 2. Because it goes through the x of the vertex. Domain, well, it's a parabola. All parabolas have a domain of all real numbers. The range comes from the maximum value or the minimum value, but in this case, a max. There is no minimum, goes down forever. -infinity on the y, but a max value up to and including -1. What are we missing? X and Y intercepts. Easy one is the Y intercept, because that's when X is 0. When X is 0, we plug in 0 for X. That disappears, that disappears. 0 plus 0 minus 5. The Y is going to be -5. So y-intercept point 0, -5. The x-intercept, this one is when y is 0. And that means set the whole thing equal to 0. And we'll do that with the quadratic formula. Let me move the y-intercept up here. So I can work in this area down here. I'm going to move domain. Nah, I'll leave that where it is. We've got enough room over here to handle the quadratic formula. A equals -1, B equals 4, C equals -5. Put that here. A equals -1, B equals 4, C equals -5. So what is the quadratic formula? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals the opposite of 4 plus or minus the square root of 4 squared minus 4 times -1 times -5 all over 2 times -1. If you're saying, when do we learn this? Last course, not last class, last course. X equals -4 plus or minus, in here, 4 squared is 16, and then minus, minus, minus. That's going to end up being a negative. -4 times -1 is +4 times -5. It's going to be a -20. Now look what happened. 16 minus 20, that says the square root of -4. Can we take the square root of a negative number? No. That means this isn't a real number. No x-intercept. Because when we tried to find the x-intercept, we got not a real number. So anytime we do this part of the quadratic formula, the b squared minus 4ac, the discriminant, and we get a negative number, that means there's no x-intercepts. If we get a positive number underneath, then just like the last time, we'll have 2 x-intercepts. And if we get 0, that means that it's still just touching the x-axis. I just drew this. If it's touching, then it happens at only one point. That's when we have the square root of 0 in the quadratic formula, or 0 for the discriminant. But looking for the x-intercept, didn't get a real answer, no x-intercept. Finally, let's use all this information to graph. We have a vertex point of 2, -1, and it opens down. Well, look, it opens down. No x-intercepts then. But we have a y-intercept of 0, 2, 3, 4, -5. And since this is an axis of symmetry, it would kind of look like that on the other side. That might be the most accurate symmetrical drawing that I've drawn today. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Well, decide what must be maximized or minimized. We have to maximize or minimize the area. Specifically, we want to maximize the area. We don't know the dimensions, but we do know that area is length times width, x times y. We were told we have 120 feet of fencing, so the perimeter of the rectangle is 120, twice the length plus twice the width. X plus y plus y is 120. If we solve this for y, we would get 120 minus 2x for 2y. Then dividing both sides by 2, we'd get 60 minus x. So y is 60 minus x. Area is x times y. So now we could write area as x times 60 minus x. We can make that substitution, y for 60 minus x. Why would we do that? Well, because now we get an x squared. And once we have the x squared, we know we have a parabola. We know we have a maximum or a minimum. We can find that maximum to maximize the area. So we start multiplying through to get rid of the parentheses, 60x minus x squared. That would be negative x squared plus 60x. We write it that way so we can clearly see our A and clearly see our B. Our A is -1, our B is 60. So negative 60 over 2 times -1. That's negative 60 over -2. That's positive 30. So the maximum, and we know it's a maximum because A is negative. That means the vertex is at the peak. It opens down. The maximum occurs at 30, but the maximum is not 30. Remember, we have to answer the question posed by the problem. Let's revisit the problem. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? So we found x equals 30. One dimension of the rectangle. Y was 60 minus x. 60 minus 30 is 30. So the other dimension is 30. Does this check out? 4 sides, all 30. That's 120 feet. That works for perimeter. That must be the maximized rectangle. What's the area then? Length times width. 30 times 30. 900 square feet. And that's it for this topic.